Ladies and gentlemen, welcome to Inerpolation tutorials. We are continuing the Rankine cycle, but on this question we are working out the question which have got a superheated steam. So we have to know how I'm going to tackle if we are having the superheated equation with containing a superheated steam. So here our question is saying in a steam turbine, steam at 20 bar, 3 degrees is expanded to 0.08 bar. It then enters a condenser where it is condensed to saturated liquid water. The pump feeds back the water into the boiler. Assume ideal processes, find out per kg of steam, the network and the self-efficiency. So here we have to mark out our pressure one here, which is our steam pressure, but our steam pressure is under the temperature of 360 degrees. Then it is going to be condensed. This is the condenser pressure, which is 0.08 bar. And then so these are our keywords for now we are going to use to obtain our information which we are going to use to answer these questions here. So firstly, we are going to start by drawing our TS diagram here. So our TS diagram here is going to be like this. Our temperature here, then our enthalpy here, then our TS diagram here is going to be like this. So here now we are going to see that here after this constant here, after this constant level we are having here, we are going to see that we are having this sharp curve which is representing the superheated steam, because we are having this 360 degrees. If our pressure is under degrees which is above 100 degrees, it means it's now a superheated steam. So this is when we are going to draw our graph like this. So here it's 1, 2, 3, 4, 5. Then here at 1 we are having this 360 degrees Celsius. Then we are going to come here, then we are going to write our steam pressure as P1, which is equals to 20 bar, but this 20 bar is under 360 degrees Celsius. So this pressure which is under the 360 degrees Celsius is the one which we are going to convert it to megapascals, because if we check on our steam table, we are going to see that on the superheated steam we are only having our pressure is in megapascals. So what I'm saying here is, if you check on your steam table, you are going to see, because here we are having saturated pressure, and then if you come here, this is where we are having the superheated vapor here. So we are going to see that our pressure is in megapascals. So it means when our pressure here, if our temperature here is above 100 degrees of this pressure, it means this pressure we are going to convert it to megapascals, because it is now under the superheated steam. So this, if we are converting the bars to megapascals, it means we are going to only divide the given number by 10. So we are going to divide this 20 by 10, then we are going to left with 2 megapascals. So we are done with this. After writing this 2 megapascals, we have to find the H1, which is the Hg of these 2 megapascals. So we have to come here, as we know that on the steam pressure, which is the pressure one, we have to just take the information of H1 and S1, then we leave it as like that. So here we have to just take the H1 of 2 megapascals. So we are going to check for 2 megapascals here in the superheated vapor. We are going to see that we have to look that we are having our 2 megapascals here. This is where we are having our 2 megapascals, and then on our 2 megapascals our temperature is 360, but we are going to see that here we are not having 360, we are just having 350 and 400. So we are going to repeat the process of interpolating here. We are going to interpolate So when we are interpolating, we are going to just take the number which is bounded, the number which we are in need. So the number we need here is the 360 degrees, but here we are just having 350 and 400. So you have to take these numbers in, that is bounding our number. So we are going to say 350, then 400 here. So 360 is found in between the two numbers. So now we have to take the h of 350 here under the 2 megapascals. Don't forget that. So here we are going to take this h, which is 3137.15. Then here on 400 we are going to take 3247.18. So after writing this, we are still in need of finding what? Our h1 for 360 degrees. So here, as I was saying, we just check if our pattern here is decreasing here or increasing. Then we are going to check that this number is smaller and this one is bigger. So we are saying that our number is going bigger. So it means it's increasing, because here we are having 3137.15, here we are having 3247.18. So we are saying that the pattern we are having here, it's increasing. So it means after getting the graduals, the values, the graduals we are need here, we are going to add on this value. So what I'm saying here is this: when we are interpolating, we just subtract this number from this one. So we are going to say 3247.18 subtracted by 3137, and then so 3247 subtracted by 3137.15. Then our answer there is going to be 110.03. Then we are going to subtract here 350 from 400, and then we are going to just get 50. So if we divide here, we are going to get 2.2006. So this value for h1 is only for one gradual here, for one gradual here. So but as we need 360, so we are going to check that from 350 to 360, how many graduals are we having here? We are going to say that we are having 10 graduals. So it means we have to multiply this this number, which is representing each gradual, by 10, so that we will be able to get the value of h1 of 10 graduals here. So that will be on 360. So we are going to say 2.206 multiply by 10. So we are going to left with the 22.006. So now, since our pattern here is increasing, so it means this number you have get for 10 graduals here, it means you have to add it here, so that we'll be able to get the hg of 360. So now we are just adding this. So we are just 137.15 plus this number you have, which is 22.006. So this is what we are going to get. So let's punch it. So we are going to get 3159.156. this is h1. So on pressure 1, you have to just find h1 and s1. So now you have to find s1. So for you to find s1, we have 350 our pressure, 400 our pressure. Then you have to just take the value. You have to take a steam table and find the number, the values of SG. So for us to get the values of SG, if you look on the steam table, we are going to see that we are having is corresponding with 6.9566, and 400 is corresponding. If we check 400 here, check our steam table, we are going to the superheated side under what? Under our 2 megapascals here. So we are going to take the values 400 for this 400 for S, which is 7. So we are going to see that our value is going to be 7.1265. So if you are done with this, we are going to repeat the process. And since we are seeing that here, we are just seeing that the values here, we are the numbers we are having here, they are just increasing. So it means after getting the values of 10, so after getting the difference between this 350 and 360, which is 10 here, so firstly let us find the difference we are having here. So our difference we are having here, if we subtract this 7.265 subtracted by 6.9566, we are going to get, our answer is going to be 0.1699, and then the total difference here we are having here between 400 and 350 is 50. So we are going to divide 0.1699 divided by 50, and then let's divide it 0.1699 divided by 50. We are going to get 0.003398, and then we know that this value is for each gradual from this 350 to 400, but to us we just need from 350 to 360. So from 360 to 360 we just have 10 gradual, so we have to just multiply this one, multiply by 10. So you're going to say 0.003398 multiplied by 10. So our answer is going to be 0.03398. So after having this value, we know that this one, our pattern here is increasing. So it means after getting this value of the 10th gradual here, we are going to add it to our HG. We are already having here on 350. So we are going to say this value 0.003398 plus 6.9566. Then we are going to get our S1 is 6.99058 kilojoules. So this is our S1. So after having this S1, we are going to jump to our condenser pressure. And our condenser pressure is not affected by this 360. So our condenser pressure is going to be just, this is 0.08 bar. So this one, since it is not affected by this temperature here, it means we are going to just turn it to kilopascals. So we are going to get 8 kilopascals here. So here, after getting this 8 kilopascals, we just need the values of HF2, and then we also need the H of G, then we also need the value of SF and SFG under these 8 kilopascals. So there it means there is a need of a steam table so that we'll be able to get those values. So on, let's check. We're just having 8 kilopascals here. So on 8 kilopascals, we are going to see that our HF here is equals to 173.80. Then our HFG here is equals to 2403.58. Then our SF2, our SF here is going to be 0.5924. Then our SFG here, we are going to just take here, which is equal to 7.6372. Then after having these values, now we have to find H2. Then our H2 is equals to HF2 plus X of HFG2. So now we have to find X here. So for X, we have to say S is equal to SF2 plus X of SFG2. So we are going to say our X1, as we know that we have the information of X1 of S1. So we are going to take our S1, which is 6. Our X1 is 0.9058, which is equals to, then our SF2, you're just going to take it here, 0.5924 plus, then our x here is the number, is the one which is in need. Then our SFG is 7.6372. So our x here, if we punch on the calculator, let us check on the calculator. So if we punch correctly, we are going to see that our x is going to be 0.838. Then after getting this x, now we are able to find our H2. So on our H2, we are going to just take our HF2 here, then our HF2.8 plus x, our x is 0.838, then our HFG, this one is going to be 2403.58. Then our H2, let us punch on the calculator, so that will be going to see our H2. So our H2 is going to be 2188 kilojoules per kg. So after having this, we have to go to the question. Then our question is saying here, find out per kg of steam the net work. So here our question is saying we have to find the work net. So we know that our work net is equals to work turbine subtract by work pump, and then we also know that our work turbine is equals to H1 subtract by H2, and then we already know that our H1 is equals to, our H1 is equals to, here we are going to say 9, we are going to say 3159.156 subtract by our H2, then our H2 we are already having it here, 2188. So we are going to get our work turbine as 971.156. This is our work turbine. Then our pump work is equals to, we're going to use the formula VF2, then a change in what? Then a change in pressure, where we're going to take our VF of 8 kilopascals. So the VF of kilopascals is 0.001008, and then change in pressure, we're going to say our first pressure, which is 20 here, subtract by our second pressure 0.08, and then our answer here, you have to multiply it by 100, so that we turn it to kilojoules per kg. So let us punch this on the calculator. So if we punch here, we are going to get our pump work is 2.008 kilojoules per kg. So we are done. So now it means we are able to, so our working net, we are just saying now our work turbine is 971.156 subtract by our work pump 008. So our working net is going to be, let's punch it. We are going to see that it's 969 kilo per kg. So this is our working net. So we are done with the working net. So now, and then it says, and the cycle efficiency. So if the question says the cycle efficiency, the formula for cycle efficiency is work net over Q1, and we know that when we need to find our working net, working net we are already having it, because our working net is this one, so we just need to find the Q1. So what is the formula for Q1? The formula for Q1 is H1 subtract by HF4, and then we need to find what is the value of HF4. So the value of HF4 is equals to pump work plus HF2. So we are going to say our pump work is this one, 2.008 plus HF2. our HF2, we are going to come here, and then we are going to find our H2 is this one. So we are going to say plus 173.8. Then let us punch it on the calculator. We are going to see that our answer is 175.808 kilojoules per kg. So now we are having HF4. So on HF1 we've already it. So we are going to say our cycle efficiency is now we're going to say our working rate, which is 969.701 over our H1. Then our H1 already know that we already write it here. This is our H1, 3159.156. Subtract by our HF4. Our HF4 this one, which is 175.08. So the answer we're going to get here multiplied by 100, since it is efficiency. So we are going to say 969.701 over 3159.156, subtract it by 175.808. So our answer is going to be 32. So our cycle, let me find the paper. So our cycle efficiency here is going to be 0.325, but I will just have to multiply it by 100. So our answer is going to be, so we're going to multiply it, since it is efficient, so you have to say 32 if you multiply it by 100 is going to be 32.5%. Thank you guys. Don't forget to subscribe, like and share.